So we've now calculated our A prime value. So A prime is in the Cartesian coordinate system. So what we need now is to take these A prime x, A prime y, and A prime z and convert them into latitudes and longitudes. Okay. So how we can do that, we have to go back to the definition of the Cartesian coordinate system. So we have AX, AY, and AZ equal to the cosine and the sine of these two angles, the latitude and the longitude. So it's reasonably easy to calculate the latitude. So we can, if A of Z, the Z component of A is equal to the sine of the latitude of the angle in radians, well, to get rid of this sine, we can take the inverse sine of both sides. So the inverse sine of AZ is equal to lambda A. So let's do that now. So lambda A nu is equal to, so in NumPy, recall the way we can, arc sine. The way we can take the inverse sine is the arc sine of A prime 2. Okay, the arc sine of A prime 2. So we can get that lambda pretty easily. What we also want is the phi A nu. This is a little bit more tricky. Okay, so if we come back to our equations again, we want to get this phi now. We want to get the longitudinal angle, but there's no easily invertible equation. So what we're going to do instead is we'll take equation 2, so this AY equation, I'm going to divide it by this first equation here. So the cosine lambda A will divide through to be 1. On the left-hand side, we'll get AY divided by AX equals sine over cosine of this angle. And sine over cosine of this angle is the tangent. So the way that we're going to get this angle is going to take the arc tangent of AY over AX. And of course, in Python, the way we calculate that is numpy.arctan2. The 2 is actually important. If you like, you could look up why that is. And we're going to take, it was y. Y was the entry in position 1, comma, A prime 0. Okay. So you might like to look up more information about this arctan2 function here and why we have a comma instead of a dividing by. But I'll leave that to you. We also want to convert these to degrees, right? So we want, well, let's just append them in degrees actually. So let's go a lat nu dot append equals, not equals, bracket, is numpy dot rad to degrees, so we're converting radians into degrees of lambda A nu here. Lambda A nu. Okay, and I'm just going to add this little 0 in here, and just I'll tell you why soon. But first, I'll also convert the longitudinal data. So phi of A nu, and this is long. So let's just, you may have seen I've added this command in here. Let's also print the longitudinal data. Let's just check that this is working, okay? So I'm going to run that now. And okay, well, it looks like we are printing out some new coordinates here. So this seems to have worked. I have the 0 here at the end. It's just a little bit to do with the data structure we've been using. So when we take the second entry of A prime, even though it's only one number, it's still treating it as if it was an array. So we just took the, well, the first entry in the array, the 0th entry in the array. Okay, so finally now, we've got all these new latitudes and new longitudes that we've, after rotating those points A around the Euler pole, all we are left to do then is plot these points. So, well, let's, we're plotting the original points here. Let's plot the rest of them here as well. Okay, so for I2, so using a different iterator here, in the range 0 to the length of A lat nu. Okay, I'm going to plt.plot A long nu II2 A lat nu II2, and again I'm just going to plot these in red, I think. So I'm going to go color equals red, line width equals 0, marker equals, I'll make them as little pluses. And again, I'm going to use the same transform. So let's see if this is working for us. I have a little issue here. Marker, oh, I shouldn't have had this thing, okay. Okay, so I have some issue here as well. Transform, I've misspelled transform. Okay, well that makes sense. Let's fix that. A lot of programming is bug finding. Okay, so now you can see that we've rotated these points in Australia around this Euler pole, which is actually past north, and we've chucked Australia into the middle of the Pacific Ocean. So I think that's worth plotting and saving that plot. So I'm going to plot.savefig rotation map.pdf. Run that one more time and succeeded. So now I should be able to find a PDF of which is called rotation map somewhere. And of course I can't find it. Rotation map. There it is. Okay, so we've taken these points around Australia and we've rotated them around this Euler pole and moved them into the Pacific Ocean. Okay, well, please give that all a try, and if you have any problems, please don't hesitate to get in touch. Thank you for paying attention.